Long and short-term effects of exercise. During exercise, the body system responds immediately to provide energy for the muscles to work. After regular and repeated exercise, these systems adapt to become more efficient. Short-term effects of exercise on the body systems. When a person takes part in exercise, the cardiovascular, respiratory, energy and muscular systems all work together to supply energy to the working muscles and remove waste products. When the muscles start to work, they need more oxygen, so the respiratory system responds by getting more oxygen into the lungs. The blood carries greater amounts of oxygen, and the heart responds to pump more oxygenated blood around the body. These effects are shown in the table. The short-term effects of exercise on the cardiovascular system: increase in stroke volume, increase in heart rate, increase in cardiac output, increase in blood pressure, redistribution of blood flow. Respiratory system: increase in breathing rate, increase in tidal volume, increase in minute volume. Cardiorespiratory system: increase in oxygen uptake and transport to the working muscles, increase in carbon dioxide removal. Energy systems: increase in lactic acid production. Muscle systems: increase in temperature of muscles, increase pliability, so more flexible. Muscle fatigue. Redistribution of blood flow. During exercise, the cardiovascular system redistributes the blood so that more of it goes to the working muscles and less of it goes to other body organs, such as the digestive system. This redirection of blood flow is caused by the mechanism or process called vascular shunt mechanism. It works a little bit like a railway terminal, where the trains are directed onto some tracks and stops from travelling onto others. The blood vessels allow lots of blood to travel to the working muscles, but they don't allow much to travel to the other organs. When the muscles stop working, the blood distribution returns to its normal routes. Warm up and cool down. Warming up before sports allows the body systems to make all these changes gradually, so they are fully prepared for the stress placed upon them during activity. Long-term effects of exercise on the body systems. Taking part in regular exercise or training around 3 times per week for 6 weeks will lead to adaptations of the body systems that used or trained. This has the effect of increasing performance in that type of exercise or sport, and is often beneficial to general health and everyday life. Long-term effects of exercise. Cardiovascular system. Cardiac hypertrophy, increased stroke volume at rest and during exercise, decrease in resting heart rate, increase in cardiac output, Polarization at the lungs and muscles, increase in the number of red blood cells. Long-term effects of exercise on the respiratory system. Increased tidal volume, minute ventilation and vital capacity, increased number of functioning alveoli, increased strength of the respiratory muscles. Long-term effects of exercise on the energy systems. Increased production of energy from the aerobic energy systems, increased tolerance to lactic acids, faster recovery rate, increased aerobic capacity. Long-term effects of exercise on the muscle systems. Muscle hypertrophy, increased strength of tendons and ligaments, increased muscle strength, increased muscle endurance, increased speed of contractions, increased resistance to fatigue. On the skeleton system, increase in bone density and strength, increased flexibility. Cardiac hypertrophy. Hypertrophy means an increase in size. So muscle hypertrophy means the muscles get bigger. If you weight train regularly doing bicep curls, your biceps will show muscle hypertrophy. Cardiac hypertrophy is where the ventricle wall gets larger or thicker as a result of exercise. The muscle wall of the left ventricle increases in size, meaning it is able to pump out more blood during each contraction, which increases the stroke volume. As stroke volume is increased, resting heart rate decreases, but cardiac output remains the same. Look at the equation: stroke volume times heart rate. Capillarization. Capillarization is the process where new capillaries are formed. Capillarization takes place at the alveoli in the lungs and at the skeletal muscles. This has the effect of increasing the amount of oxygen that can be transferred to the working muscles, as well as increasing the amount of carbon dioxide that can be removed. Effects of exercise on the cardiovascular system. Changes to the heart rate during exercise. Heart rate is measured in beats per minute. During exercise, the heart rate increases so that sufficient blood is taken to the working muscles to provide them with enough nutrients and oxygen. An increase in heart rate also allows for waste products to be removed. Maximal heart rate can be worked out from the following equation. Maximum heart rate equals 220 minus your age. Change to stroke volume during exercise. Stroke volume increases, which means more blood is pumped out of the heart each time it contracts. Changes in cardiac output during exercise. At rest, a person's cardiac output is approximately 5 litres per minute, while during exercise it can increase as much as 30 litres per minute, as both their heart rate and stroke volume increases. Changes in blood pressure during exercise. As exercise increases, cardiac output also increases. This has the effect of increasing blood pressure. A typical blood pressure reading for a person at the start of exercise would be around 180 to 85. Effects of exercise on the cardiorespiratory system. The cardiorespiratory system works together to get oxygen to the working muscles and remove carbon dioxide from the body. During exercise, the muscles need more oxygen in order to contract, and they produce more carbon dioxide as a waste product. To meet this increased demand by the muscles, the following happens: breathing deeper or breathing depth, tidal volume, and rate increases. This gets more oxygen into the lungs and removes more carbon dioxide out of the lungs. Heart rate increases. This increases the rate that oxygen is transported from the blood to the working muscles, and carbon dioxide is transported from the working muscles to the lungs. So you can see that the heart rate at rest stays still. As you start to exercise, it moves up. As you start exercising, it moves back down to rest. Have a go at these exam style questions. Once you finish them, bring them into class and we can go through them together.